All right, so number 16, we're actually graphing. And so we have an equation here, or excuse me, an inequality, right, that is already in slope-intercept form. So and instead of an equal sign, we have a less than or equal to. So it's an inequality, but it's in slope-intercept form, right? We have the y, the mx, and the b, right? And so we could graph this just like we normally would, right? So I'm gonna plot the y-intercept, right, which is 3. And then I'm going to use the slope to find the next point. So the slope is -1/2. So I'm going to go down 1 and over 1, 2, right? And then I'm just going to connect the dots using a straight edge. All right, so there's the line. And remember that because, and I should have mentioned this just slightly before I graph the line, but remember, because it says or equal to here, because of that, we're going to have a solid line, right? Okay, and so now we can just figure out, okay, well, are we going to shade above or below? Because remember, an equation represents all the points on this line, right? There's an infinite amount of points on that line, but since we have also a less than, right, we have or equal to and then a less than, that means we're also going to shade everything below, right? So we're going to shade all this area below here. Okay, so not only does an inequality, or not only can it include the line, but also includes everything above or below the line, right? Which is a lot of points, right? Even more than the line itself. Even though the line is an infinite amount of points, with the inequality we have even more. All right, so that's how you graph an inequality. It's basically the same thing, except you're going to shade above or below the line, or to the left or the right if it's vertical. Okay. Now let me just review real quickly. So if you have a less than or equal to or greater than or equal to, remember that's when you have a solid line. Okay. And if you just have a regular less than or greater than, that's when you're going to have a dash line or a dotted line. Okay. And then if it's less than or less than or equal to, you're going to shade below, or sometimes left, to the left. If it's greater than or equal to, you're going to shade, that's going to be a greater than, you're going to shade above or to the right of if it's vertical. Okay. All right. So let's check out this next one, number 22. So this time we don't have the equation in slope-intercept form, so we have to solve for y, right? We have to get y by itself. So a few things, I can do this a few different ways. I can move the 2x and the 3, and then get the y to be positive by dividing by -1 or multiplying by -1. But it's probably a little faster to just add y to both sides. Okay, so then I get 2x plus 3 is greater than or equal to y. So I'm going to flip this around. And with an equation, we can just flip it, no problem. It's symmetrical, but with an inequality, we have to flip the inequality as well, right? Because y, if we read it backwards, y is less than or equal to, right? Or this is greater than or equal to y, right? So I want to make sure that y is less than or equal to. I want to make sure the inequality is still pointing to y. Okay. And so now it's the same thing. We identify the slope and the y-intercept. So the y-intercept is 3. So we can plot the 3. And the slope is 2. So I can go positive 2. So I can go up 2, 1, 2, and over 1. Right? And then since it's or equal to, right, it's going to be a solid line. So I can graph this line here. All right, and then since it's less than, we're going to shade below. Okay, so we're going to shade everything below this line here. All right, and that's it. Okay, so here we have a horizontal line, right? We just have y without an x. So we know there's going to be a horizontal line, okay? And it's going to cross through y equals 2, right? So we're going to have the y-intercept here, okay? It's an or equal to, so it's going to be a solid line, right? And since it's greater than, we're going to shade above, right? Okay, so I'm going to graph the line. And then we're going to shade above. Okay. All right. Try the next one. So here we just have x equals, or not x equals, but x is less than a number, right? So we have x inequality with a number. So we know there's going to be a vertical line. However, since there's no or equal to, it's going to be dashed. Okay. So it's actually going to be dashed like that, right? And then since it's less than, that means we're going to shade to the left, right? All the numbers less than 1 are to the left of 1, right? If we're on the x-axis. So when I graph this, I'm going to plot a point at 1 on the x-axis. I'm going to draw a dashed line. Okay, and then I'm going to shade everything to the left, since it's less than. If it were greater than, we'd shade on the right. Okay, all right, so there it is. All right, so on this example, we have 2x minus 5y is greater than or equal to 10. So let's actually make that just a greater than, because we've seen a lot of or equal to's. All right, so, and so I changed it, so 32 in the book is a little different. I changed a couple things about this one, but I want to show you a few things that we haven't seen yet. So first of all, I want to get y by itself, right? So treat it as if this were an equal sign for the most part, right? So I'm going to subtract 2x from both sides. So then we get negative 5y is greater than negative 2x plus 10. Then we can divide everything by negative 5. And here's where the difference is between equations and equal signs in terms of manipulating each side of the equation, is when you divide by negative. So see how there's a negative on the bottom? When you divide by a negative on both sides, you flip the inequality around. So it turns from a greater than to a less than. So we get y is less than negative 2x divided by negative 5 is positive 2 over 5x, right? And then 10 divided by negative 5 is negative 2. So you flip the inequality sign around whenever you divide or multiply both sides by a negative, okay? So it doesn't matter that there's a negative or positive on top. It matters what you're dividing by, right? So what you're doing on both sides. All right, so now we're back to what we've done before. We see that our well, let me address the inequality first. So since it's less than without an or equal to, we're going to have dashed, right? And since it's a less than, we're going to shade below. Okay, so let's start with plotting the y-intercept. So it's negative 2. So I'm going to put a dot there, negative 2. And then the slope is 2 over 5. So I'm going to go up 2, 1, 2, and write 5, 1, 2, 3, 4, 5. And now we can connect the dots. All right, so it's going to look something like that. And then we want to shade, so it's going to be dashed like we talked about, because there's no or equal to here, right? And then we're going to shade below, because it's a less than. There we go.